Hi, my name is Emma, and my project is called Developing an Ambient Light Lock-in UV Fluorescence Imaging System for Enhanced Forensic Evidence Detection. Basically, I wanted to solve a real forensic problem. Fluorescent evidence, like latent fingerprints or biological residues, glows under UV light. But the problem is that it's very faint. In normal room lighting or daylight, that glow gets completely overwhelmed by ambient light. That's why most forensic UV detection has to happen in dark rooms. So I asked, what if instead of turning off the lights, we digitally removed that background light? That's where the lock-in modulation comes in. Lock-in detection works by flashing the UV light on and off very quickly, in my case between 50 and 500 hertz, and then using image processing to isolate only the light that matches its flashing pattern. Since ambient light doesn't follow that pattern, it gets removed during processing. To build the system, I used a set of UV LEDs, an Arduino Nano board to pulse the LEDs, a MOSFET driver circuit to safely control current, a long-pass optical filter to block reflected UV, and a smartphone camera mounted onto a tripod. I applied fluorescent residues and latent fingerprints to 5 common forensic surfaces: glass, plastic, metal, wood, and paper, and I tested them under 3 lighting conditions: indoor, bright indoor, and daylight. I recorded burst mode videos while the LEDs pulsed. Then I imported the frames into ImageJ in Python, separated them into LED on and LED off groups, and performed pixel-wise subtraction and demodulation to isolate the fluorescence. To measure the performance, I calculated signal-to-noise ratio, contrast ratio, and I ran statistical analysis using a 2-sample t-test. Across total 20 trials, the results were statistically significant. The average signal-to-noise ratio increased from 1.66 with static UV imaging to 5.70 with lock-in UV imaging, which is over a 240% improvement. The p-value was 0.002, meaning the improvement was highly unlikely to be due to chance. Contrast ratios also increased substantially across all surfaces and lighting conditions. What this means is that the lock-in system was able to reduce background interference and make faint fluorescent evidence much more visible even in daylight. These are the limitations. I only tested flat surfaces and I didn't vary environmental factors like humidity, but future work could include real forensic samples, curved surfaces, and hardware level synchronization for even better performance. Overall, my project demonstrates that ambient light lock-in UV imaging can significantly improve forensic evidence detection using a low-cost portable system. And instead of needing a dark room, investigators could potentially use this technology in real-world environments, improving accuracy, reducing missed evidence, and making forensic analysis more practical in the field. Thank you.